I'm going to try to do some 12-4 videos from home. I wanted to try this out to see if this works. So let's give it a try. This might be a little rudimentary. Fundamental theorem of algebra says that every polynomial equation has at least one complex root. That complex root could be anything from 1 plus 2i to just 1. So it doesn't have to be, just to be complex, you can have the imaginary part being 0. So then if we have a linear factors, if we multiply all these factors, these roots together, you get the polynomial. They may not be distinct, which means that they could be a repeated factor like x minus 1, x minus 1, two of those. To determine the equation of a polynomial in the general form with the zeros -5, 2, and 3, and that the graph has to pass through 0, 1. So this is my first workout problem. So I have it worked out here on a whiteboard. Let's see if we can get it to zoom in on this. So if my zeros are at -5, 2, and 3, that would make my factors x plus 5, x minus 2, and x minus 3. If I FOIL all that out, I end up with x cubed minus 19x plus 30. And if you recall, the question originally said that it has to go through the point 0, 1. So when I plug in the point 0 in for x here at f of 0, I get 30. So I have to change my function to g of x and then multiply the whole equation by 1/30. The second workout question that I have is right there, and let's see if we can. Is r sub 1 is equal to 1 minus 2i, and r sub 2 is equal to 1 minus 2i. And so these are the roots that I would get if I use the quadratic formula on a quadratic, but in this case we're going backwards. So here I have the factors, x minus 1 plus 2i and x minus 1 minus 2i. And if I FOIL that out, notice how I do this. I multiply the x times all three of them, giving me this first line, and then -1, and I line up the like terms, and then multiplying the 2i times all of them and lining up those terms. If you do that, the simplifying seems a little bit easier because the -2ix and the positive 2ix, they kind of go away, and the plus 2i and the -2i go away. And so simplifying, I get x squared minus 2x plus 6. In addition, in the question, and we can probably go back to it here in a second, it asked you to find the max or min, and so I use the equation x equals -b over 2a, which is the axis of symmetry for any parabola, which gives me an x equals 1. Plugging that in gave me a 5. So I knew that the minimum point of this parabola is at the point 1, 5. I know that it's a minimum because it opens up, because it's a positive x squared, so it opens up. And let's get back to this. And every polynomial of degree equation is multiplicity, and determine the relationship between them. And so the relationships between in a quadratic. And so then we're going to talk about some of the relationships between the roots of a quadratic. quadratic and the roots relationship in a cubic. So I've got that on another whiteboard. And if I take the quadratic here first, we know that the quadratic of the form x squared plus bx plus c, if my roots are r1 and r2 like I have up there, then the relationship between them ends up being that r1 plus r2 is equal to negative b, and r1 times r2 is equal to the c value. Now let's look at some of those relationships when we go to a cubic. Again, my roots in a cubic are going to be r1, r2, and r3, and so r1, r2, and r3 so the relationship between r1, r2, and r3, we add them together, we get a negative b. If we add each combination of those three, r1 and r2, r1 and r3, r2 and r3, that's going to give us our c value. And if we multiply them all together, we get our negative d. So that's kind of interesting. And so then the last thing that I wanted to talk about was we have the quadratic formula, but let's see if I can get that. There's also a cube root formula for factoring cubes of a certain type. So let's see if we can run through one of those. And let me see if I can get the whole formula in there. It's in your book. So there's the whole formula. And I chose to use x cubed plus 4x equals 64 as my practice one. And I plugged it all in. I'd encourage you to try this. And there I left it as 27,584 over 27. And down here I simplified it. Over here I just went decimal and I came up with 3.666. And then I used the same thing on my calculator. I don't know if you'll be able to see it on the calculator. And I guess you won't. Well, I hope this isn't terrible.